Hello, in this short video we're going to talk about Karnuagh maps. What are Karnuagh maps? Karnuagh maps are a graphical method used to simplify Boolean algebraic expressions. In the previous chapter we have seen how to use the numerously available algebraic properties to simplify a logic expression. And Karnuagh maps is a better way because it shows you how to optimize a logic circuit graphically without having to memorize the numerous algebraic properties. As I said, a Karnuagh map is a graphical representation. It consists of a two-dimensional cells arranged in a grid fashion like the one shown on the right hand side here. And each cell represents an input combination for a given function. So let's say consider a function that we have here, a simple function. It doesn't have any specific output, but let's say there is a logic circuit with inputs A, input B, and output F. And as we know, when you have a circuit with two inputs, you have four combinations as shown here: 0, 0, 0, 1, 1, 0, and 1, 1. So it doesn't matter what the output is for right now. Let's go with condition 0, 0. When we say 0, 0, each input is given a minterm. So how do we write the minterm? Let's see here. Since A is 0, we start with, it's going to be, minterm is going to be A bar. Since B is 0, it is going to be just B bar. Okay, so let me restart this. I did a simple mistake. So let's write this down. Minterm, every minterm is going to have all the inputs here, A, B, in its true or complement. So let's see here. It has A, B all. So how do we write minterm? Since it's 0, 0, if it is 0, put a bar by the input. If it is not a 0, just leave it as a true function. A is 0, so I did a bar. And here B is 0, so I'm going to do a bar here. So the minterm for 0, 0 is going to be A bar, B bar. Next come to input 0, 1. Input A is 0, so I'm going to write A bar. And B is 1, so I'm going to leave it as is. So for input 0, 1, the minterm is going to be A bar, B. Similarly, for input 1, 0, the minterm is going to be A is 1, leave it as is. B is 0, so put B bar. The last one, input 1, 1, is AB. So here, for the input function of inputs AB, we have minterms A bar, B bar, A bar, B, AB bar, and AB. Now, we have minterm, and each one of these is given a number. How do we find this number? It's quite simple actually. If you look into this number 0, 0, what is the decimal equivalent of 0? 0, 0. It is 0. So it has a minterm number of 0. Next one, we have input 0, 1. The decimal equivalent of 0, 1 is a 1. So minterm number is 1. The next one is input 1, 0. 1, 0 decimal equivalent is 2. So minterm is 2. The last one, input 1, 1. Decimal equivalent of that is 3. So minterm is going to be 3. And the short notation, there is a short notation for these minterms. We don't often write A bar, B bar, A bar, B, AB bar, AB for each and every minterm. We just write the short notation. A bar, B bar, it doesn't matter what minterm it is, it starts with a lowercase m, and since minterm number is 0, we write m0. Minterm number is 1, so we write m1. Similarly, m2 and m3. Okay, this is how you write a simple notation here. So let's see here. How do we simply solve a simple problem? So here on the left hand side, I have problem 1. I given a circuit with inputs A and B, and I have an output F function. Okay, so what we are asked to do here is to simplify this function. So let's see how to write it. So here we have inputs A, B, F is 1, and on the right side we have a simple table K-map for a two-input function. As you can see here, on the top, I wrote A here. A represents on one side and B is on the other side. So A could have two values. A could have 0 and 1. So we have a 0 and we have a 1. So what we are saying is the first row, first column, all the elements in the first column have inputs A is 0, and all the elements in the second column have input A is 1. Similarly, all the first row elements have B is 0, and all the elements in the second row have B is 1. So with this presumption, let's go ahead and fill our numbers and see. First one, A is 0, B is 0. So identify the cell where A is 0, which is the first column, and B is 0, which is the first row. So we're talking about this cell. My F is 1, so this one goes right here. The next one, A is 0, so the first column is A is 0, and the second value, B is 1. My B is 1 in the second row, so which is here. So we have to write this F value, which is a 1, down here. So the nice thing about K-map is that all what you're concerned here are about ones, and you don't care about zeros. Disregard the zeros, just focus on the ones. So now what? There are a couple of conditions we have to see here. I want to point out grouping conditions here. Okay, the point we have to remember here is optimization. To optimize, you have to group them into groups of ones of sizes 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on and so forth. In other words, you could have groups of sizes only these sizes here: 1, 2, 4, 8, 16, 32, and so on. That is the first rule here. The second rule is that we can group only horizontally or vertically. So we can group two elements this way, or we could group two elements going this way. We can do this way, or we can do this way. But we cannot do diagonally, is absolutely not allowed. So with that, let's go ahead and look into our problem. So here we have two ones. As you see here, these are available vertically. So basically we can group them, and I'm going to call this, let's say, group 1. And if we have any multiple groups, our function is going to be summation of those groups: group 1 plus group 2 plus group 3 plus so on. Here we have only one group, so my function is going to be G1. So how do you write G1? Let's look here. Group 1. Look into the cells in under group 1. Does the value of A change in group 1? The value of A is 0 here, and the value of A is 0 here. So A does not change. So we're going to write A here, but since it is 0, we're going to write A bar. And now come to B. This entire group, my B initially it is 0, and the next cell B is 1. So is B changing? Yes, here B is 0, here B is 1. So B is changing. So we disregard B. So overall function is F equals A bar. That is our overall function for this problem. So let's look into a different problem. What if problem 2, we have inputs X, input Y, and Z is a different input here, output here. So let's look here. The same way, since we are focused on only ones, not the zeros, let's jump directly into row 2, where X is 0, Y is 1. Identify the cells where X is 0, which is the first column here, and Y is 1. Y is 1 in the second row. So we're talking about the cell in the bottom left here. So this one will go directly here. Now let's talk about the second one. Here, the one in the third row here, x is 1, so we're talking about elements in the second column, and y is 0, we're talking about elements in the first row. So our this one would be going literally down here. So now we filled all the K-map. Now let's talk about grouping. So can we form any groups here? There are two ones, but we cannot do diagonally. We can do vertically or horizontally. And the group sizes allowed are 1, 2, 4, 8, 16, and so on. Here we have only one group here, we have one group here. So we'll call this group 1, we'll call this group 2. So our function f is group 1 plus group 2. So group 1, let's look here, which is group 1. Group 1 in this entire cell, what is the value of x? X is 0, so we write x bar. And y here is y is 1, so we write y. Plus group 2, here is group 2. The value of x is what here? X is 1, so we write x. The value of y is 0, so we write y bar. So our function f is x bar plus y bar. In the next video, we're going to look into how to optimize logic functions using 3-input K-maps.